In this tutorial, we'd like to create a pin. Here we have a finite element model. We're going to use the scroll wheel to zoom into the model where we'd like the pin to be located. Then we're going to select Create. In the drop-down, select Pin. The first thing we need to do is enter a unique node number for this feature. This node number must not be previously used in both the finite element model and the RapidConnect model. The next step is to enter a value for the radius of the pin. In this case, this is a constant radius pin. If you already know the radius of your pin, you can enter it here. If you don't know the value, you can use the trinodal selection tool to measure the radius of the pin bore. We can see the radius is roughly 20 millimeters, so I'm going to enter 20. Next, we need to add a point on the axis that the pin will run along. We will use the trinodal selection tool to do this. The next step is to define the cylinder axis. This is done by using the trinodal selection tool to define a plane on which a normal vector that passes through the axial point lies. Moving on to optional parameters, we can see that two are selected by default to fully define the pin feature: axial bounds and tolerance. The axial bounds parameter is used to define the length of the pin. The positive axis of the pin feature was defined by the cylinder axis in the previous step using the right-hand rule. In this case, I know the pin length should be 100 millimeters. Therefore, the left bound is 0 and the right bound is 100. The final step is to define a radial tolerance. This is used as a cushion for the pin radius defined earlier. By default, this parameter is set to 2 millimeters, but this value may require adjustment depending on the tessellation of the finite element model. With this value set, we can click Apply to create our pin.